It is now my pleasure to present our departmental awards. All of the award winners today will receive a certificate and prize check in the mail. First, the BME Program Award goes to Dalton Nelson. Tuning in today to our celebration are his mother Paula, father Wayne, grandfather Richard, and sister Bree. Dalton's from Kansas City, Missouri. He was in a special 3-2 dual degree program with the William Jewell College in Missouri. He spent his first 2 years there and then last 2 years at Vanderbilt. He finishes with a Bachelor of Engineering in Biomedical Engineering from Vanderbilt and a Bachelor of Arts in Math and Philosophy from William Jewell, plus a minor in physics there. He earned a perfect 4.0 GPA at both institutions. Dalton distinguished himself in undergraduate research while he was here, working with Professor Rick Hazelton. Dalton worked on a device for the detection of drug resistance mutations in HIV. This work has received a lot of attention in the news. He presented his work at the annual conference of the Biomedical Engineering Society last fall. He also completed research projects in the fields of mathematics and in physics while at William Jewell. Dalton was vice president of the running club at Vanderbilt. This summer, he will be a hiking guide in the mountains of Colorado. And after that, he'll return to Vanderbilt and he'll start as a PhD student here in biomedical engineering. Dalton will continue his research in the Hazelton lab, working on low resource diagnostics and microfluidics. Dalton shared with me the fact that he applied directly to Vanderbilt out of high school and didn't get accepted. I share this fact with you by noting that now here he is graduating from Vanderbilt and receiving our highest award in biomedical engineering. I think that says a lot about his character. And I hope you'll join me in congratulating Dalton. Congratulations. All right. Our next prize to present is the Arnold Prize for Undergraduate Research in Biomedical Engineering. And this year's awardee is Tejas Subramanian. Tejas is from Acton, Massachusetts, near Boston. And tuning in today to our celebration are his mother, Rajshri, and his father, Gopal. Tejas finishes with minors in chemistry and scientific computing. Tejas has done undergraduate research in my laboratory, the King Lab, since August 2017, with a short break in spring 2019 when he studied abroad in Madrid. His research project was focused on the protein trail as an adjuvant therapy for oxaliplatin-resistant colorectal cancer. He worked closely with my PhD student, Josh Greenlee, an NSF graduate fellow. Oxaliplatin is the first-line therapy for colorectal cancer, but many patients develop resistance and their tumors stop responding to the drug. Together, Tejas and Josh discovered that drug-resistant cancer cells become sensitized to death by the protein trail, which my lab has studied extensively. Tejas became an expert in bioinformatics analysis and identified a group of genes that are upregulated in the drug-resistant cells and another group of genes that are downregulated in the cells. Tejas closed the loop on this study by demonstrating the role of these genes in cancer cell experiments, and furthermore explored the mechanism by finding that the trail receptors on the surface of the cancer cells organize into lipid rafts on the membrane surface. This finding has important implications for the treatment of drug-resistant colon cancer and gives us a lot of ideas on new research to investigate. Tejas completed his BME honors thesis, and this work will be published in a journal article, hopefully later this year. Tejas will spend a gap year at Capital One, and then he'll enter into medical school. His plan is to complete a combined MD, MBA program. I asked him how he got interested in medicine and if one of his parents is in the field. He told me that no, both of his parents are computer scientists, and that this seemed, quote, really boring to him. So he decided to study biology instead. So it appears mom and dad did inspire his career path after all. Congratulations, Tejas. Okay, finally, the Arnold Prize for Best Design in Biomedical Engineering goes to the Smart IV tubing clamp for the Nicu, that's the Neonatal Intensive Care Unit. First, I'll introduce all 5 team members, and then I'll tell you more about the project. Jory Budzikowski from Chicago is our first team member. She did research with the Bordenstein Molecular Biology Lab and was particularly active in outreach to local high schools and middle schools. In the fall, she will begin work on her PhD in biomedical engineering at Northwestern University and will work on a project related to rehabilitation engineering. Second team member, Stephanie Molitor, is from Denver. She was active in the cyber program, and their 3D printers proved very useful for this design project. She will be returning to Vanderbilt to complete her accelerated master's degree, continuing her research on exoskeleton devices with Professor Carl Zellick. Maddie Schmall is from Chanhassen, Minnesota, near the Twin Cities. Maddie did alternative spring break for 3 straight years, working on environmental conservation, helping the homeless, and people with disabilities. In July, she will start as an R&D engineer at Boston Scientific. Katie Ufford, from outside of Detroit, Michigan. Katie was the vice president for recruitment for the Alpha Chi Theta sorority and performed computational MRI research with the Agas lab in electrical engineering. She will be working with Deloitte in Washington, D.C. in the government and public sector. And finally, our 5th team member is Rachel Wellscott from Grand Rapids, Michigan. Rachel served in a leadership position with the Alternative Spring Break Organization and did a summer research project with the Naval Medical Research Unit in San Antonio. In the fall, she will work on her Master's of Engineering degree at Duke University with a concentration in medical device innovation. Now about the project. The team's clinical advisor was Dr. Leon Dupree Hatch III, a doctor in the Nicu. Now, neonatal patients can have as many as 10 IV tubes connected to them at once. And the unmet need that this project addressed is to develop a smart clamp that can communicate electronically, whether it is in the open or closed position, both with an LED light display on the clamp and remotely to a nearby tablet computer. The device will shorten the protocols and reduce human error. The team was fortunate in that they prototyped the device early and were able to iterate through 4 or 5 computer-designed 3D printed housings, with the final version not much bigger than a non-sensing traditional tube clamp. And the team shared with me the real secret to their success, which was a design locker packed to the gills with Starburst candy and a padlock to protect this supply. Congratulations to the Smart IV tubing clamp team.